Well, with all the triangles that we've had in this class so far, they always had to be right triangles. But what if it's not a right triangle? What if you have just any old triangle like this one right here? And this is angle A, go across from that. This is side A. So the capital will be the angle, the lowercase will be the side across from it. And then this is going to be angle B, and across from it, this is side B. So the formula for the law of sines is actually very easy. It says take the sine of A and divide by its opposite side A. Take the sine of B, divide by its opposite side B. And those two are equal. Now it could be that you invert them. So it could be that it's little a over sine of A equals lowercase b over sine of B. You could set it up either way and you'll get the same answer in the end. So for example number 1, suppose that this is the triangle. So this is 20 degrees, this angle is 60 degrees, this side is 12, and this side is x. Now, one thing you need to make sure when you use the law of sines is at the end, the answer makes sense. And by that, I just mean this angle 60 is bigger than this angle 20. So that means the side opposite 20 is going to be smaller than the side opposite 60. So if I do the math and I get x equals 14, I know that that's wrong. I set it up wrong or I did something wrong because across from 60 is 12. So across from 20, this is going to be, I'm thinking maybe 2 or 3. Okay, now let's actually set it up. So like I said, you can set it up either way you want, with the sides first or with the sine first, but I start with the variable first. So start with x. And then you need the angle that's across from the x, so it's going to be sine of 20 degrees equals, and because I put the side on top, I need to be consistent and put the side 12 on top, and then opposite of it is 60 degrees, so sine of 60 degrees. Now the reason that I start with the variable is because it cuts down on the work. Now to solve for x, all I need to do is multiply both sides by sine of 20 degrees. And then these cancel, and then use a calculator. So notice that the calculator's in degrees mode because this is degrees. And then it's 12 times sine of 20. And that gets divided by sine of 60. And the answer is a 4.7. Personally, I thought it was going to be a little bit smaller than that, but that's fine. 4.739. There's number 1. Then for example number 2, how about if it's got a big angle right here, and this big angle is 110 degrees. This angle is not known, but across from the theta is a 2. And across from the 110 degrees is a 16. So smaller angle, smaller side, bigger angle, bigger side. And I'm going to start with the variable. So it's going to be sine of theta and then divided by its opposite side. So sine of theta divided by 2 equals, and then do sine of 110 divided by its opposite side. So there's just a little bit of work in order to solve for the theta. One thing would be multiply both sides by 2 so that these cancel. And then take sine inverse. So it's going to be sine inverse of this. I could actually reduce. That's going to be an 8 on the bottom. So it's sine of 110 degrees, which is divided by 8. And then take sine inverse of all of that. So how much is sine inverse of sine of 110 divided by 8? So this again is in degrees, so it's going to be a pretty small angle. It equals 6.746 in degrees. Then for example number 3. So suppose that, always forgot to put 3. So suppose that this bottom angle right here is what we're looking for, x degrees. So that is a pretty big angle. So this would be 90. That would be more like 120, just as an approximation. And let's say that this side is 112, and this side is 108, and this angle is 8 degrees. Now, hopefully right now your brain is saying, wait a second, that doesn't make sense. If this is a huge angle, this should be way bigger than this, and it's only a little bit bigger. Good thinking. But let's see what happens. Oh, I forgot to set up the equation. So I'll start with the x and go sine of x divided by its opposite side. Equals, and then it's going to be sine of 8 degrees divided by 108. So then, in order to solve for x, multiply by both sides by 112. And then take sine inverse. So how much is that? Sine inverse of sine of 8 degrees. And then that's times 112, and that's divided by a 108. And it equals an 8.298 degrees. So what that means is the way that I drew the picture is incorrect. If these two sides are very close to each other, then these two angles, which are opposite of these two angles have to be very close to each other. So it's actually an 8.298, so the math is correct, even if I did not draw the picture correctly. Okay, then this is similar to a couple that they have in the homework. Example number 4. In triangle ABC, find angle B. So it's going to be a bit of a word problem, and then we need to draw the picture and set it up. So A is 30 degrees, lowercase b equals 40 feet, and lowercase a equals 10 feet. So let's see, 30 degrees, that would be approximately like this. So that is approximately 30 degrees. Now, the thing is, if I want to draw it sort of correctly, how far out should I draw this line? So this is going to be A, and I could have this be B once I'm done, and then C is going to be either way up here, or is it going to be right here? Well, B seems to be the bigger side, so it's a lot bigger than the A. So it seems that across from B, this is going to be 40, and across from A, this is only 10. It's still not drawn to scale, but like I was demonstrating with the last one, even if you do not draw it perfectly correctly, the math will turn out true. The math will not lie to you. Okay, so I'm supposed to find B, so I'm going to start with that. So sine of B divided by 40. And then I need to go the sine of 30 divided by 10. And like with the last two, there's two more steps. One is multiply both sides by 40. And then to solve for B, take sine inverse of both sides. And this I could reduce, and it would just be a 4. Sine inverse of sine of 30, and then stop the sine function, and then times 4. Uh-oh, that's not possible. Why is that not possible? So I know the drawing of the picture, it doesn't have to be that accurate, so it's not that. What does the calculator not like? So put go to, and it doesn't like what's right in here. So let's back up a step. So we would have had sine of B equals, and then I just reduced this, so I'm pretty sure I did that part right. Sine of 30 times a 4. So the cursor was sitting right here, so it's saying it doesn't like this part. What's wrong with that part? So if you just have sine of 30 and then times 4, what's wrong with that? It equals a 2. What's wrong with the 2? Oh, I know what's wrong with it. It's saying sine equals 2. But you remember from graphing, the very biggest that sine gets? The very biggest it gets is 1. So it can never equal 2. So this one has no solution. So I didn't do anything wrong, it's just that this setup is actually not possible. Okay, then on to an application or word problem. So for example number 5, there's a ship out on the ocean and it's going past a lighthouse. At one point, the bearing is from the south 28 degrees to the west. So by this I mean from the ship. So the person on the ship is looking over to the lighthouse, and then they see it by looking from the south 28 degrees towards the west. And then after sailing 7 miles, then the bearing is from the south 22 degrees towards the east. Now we did problems like this with bearing in the past, but I had to make them up, or the book had to make them up, so that it always created a right triangle. But now we don't have to. So then the question is, what is the closest the ship gets to the lighthouse? So let's say that the lighthouse is right here. And the ship is out here and it's sailing along for 7 miles. So at one point, the bearing was go from the south. Oh, actually, southwest. I'm going to have to put that over here. The ship must have been going that way. I thought the ship was going that way. So it starts here with the southwest. So from the south line, then go 28 degrees towards the west. And then they're looking at the lighthouse. So this is 28 degrees towards the west. And I guess I could just continue that line. So then they sail for 7 miles. That's the sound an airplane makes, Craig, not a ship. That's okay. Okay, then this other bearing is from the south line, go 22 degrees towards the east. So this is 22 degrees. All right, now what? So this angle is 28, and then in total this would be 90. So this one right here would be 90 minus 28. So 90 minus 28 is 62. So this one is 62 degrees. And this one would be 90 minus 22. 90 minus 22 is 68 degrees. And then I could even find this angle right here because the 3 angles of a triangle have to add up to 180. So if you take 180 minus 62 minus 68, that's 50 degrees. Now what I need to do is, so basically the closest is when it's going to be right here. So if you make a perpendicular right here, that would be the closest. So this is what I'm actually looking for, this length right here. But I'm going to have to find other stuff first, like what's the length of this line and what's the length of this line. And then I could draw a right triangle right here, and then I could find out this length. So let's say that this one is x. Then solve for x. So I'd have x over sine of 68 equals, and then 7 over sine of 50. So in order to solve for x, multiply both sides by the sine of 68 so that these cancel, and that will be x. So 7 got multiplied with sine of 68, and it's divided by sine of 50. So x is 8.472. Okay, now I'm ready to make this a right triangle. So this right here, if you make a perpendicular, that's the closest that it's ever going to get to the lighthouse. So this length would be farther from the lighthouse. This is farther. This is actually the closest. So now we need to find this, and I'll use C for closest. Well, this is now a right triangle. I can't use this 7 because the 7 means the whole side, but I can use this x and I can use this 62, and this is now a right triangle. So let's see, if you're using 62, this would be opposite and hypotenuse. So it's going to be sine of 62 equals the opposite over the hypotenuse. And the hypotenuse is x, which we just found out is 8.472. And then to solve for c, just multiply both sides by 8.472. And then just put that in a calculator and we're done. So 8.472 is my last answer, so I'm just going to go times. So 8.472 times sine of 62. And the closest is 7.481, and this is in miles.